Hey everyone, how you all are doing? Welcome to JD's Guidance, and friends, this is the video on efficient frontier. Now, to connecting this topic with the previous topics, what we have seen so far is how to calculate the portfolio risk and return. We have seen if there are n number of securities or if we have more than 2 securities, how we can calculate a portfolio returns and portfolio risk with a lot of calculations of variance, covariances, etc. I recommend you to go through the previous video on computation or calculation of portfolio risk and returns. In this video, we are starting with a topic called efficient frontier. Now friends, when we are investing in portfolio, we are generally looking for the most efficient portfolio, the best portfolio. Now the question is, which one is the best portfolio? Actually, a portfolio which gives you maximum return with the minimum risk is the most efficient portfolio. And you are continuously as an investor looking for the most efficient portfolio. To discover this efficient portfolio, we have to understand the concept of efficient frontier. This is a graphical explanation to efficient frontier, but before that let's understand one thing. Suppose we have the portfolio returns and we have the portfolio risk. As you know, portfolio risk is been measured with the help of variance of the portfolio. Now suppose we have a portfolio A, portfolio B and portfolio C, portfolio D and portfolio E. Suppose this provides a return of 200 with the variance of 150. It provides a return of 250 with the variance with the risk of 180. This provides 300 with the risk of 200. This provides a return of 300 with the risk of 210. This provides a return of 250, okay, or you can say 280. This provides a return of 280 with the risk of 180. Now, you can see that the risk and returns are given respectively for the portfolios. One thing you may observe here is that portfolio C and portfolio D gives the same amount of returns, but we would choose portfolio C because it gives the same return with a lower risk. Here it is 210, this is 200. Similarly, you can see that portfolio B and portfolio E has the same risk, 180, 180. But we will choose portfolio E because it provides a higher return with the same amount of risk. So this is the concept that we have to keep in mind when we understand the efficient frontier. So let's check what is efficient frontier. Now suppose this is an axis. OX represents the portfolio. Suppose I represent this as portfolio variance. And suppose this is the portfolio returns. This is the return of the portfolio and this is the risk of the portfolio. Okay. Now, we have to identify the most efficient portfolio. Okay. Now, suppose we have certain portfolios here, 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 here and suppose here. Right. So, let's name it A, B, C, D, E, F and G. Let's have another one, say H. Now let's understand that out of these portfolios, which one would be the one which has the, which can be considered as the efficient portfolio. Now friends, let's do one thing. We will connect all these points first. Okay. Suppose H is here. So we connect all these points first. Now, please draw your attention to the point F. Now, you see, the point F gives you this much, takes this much risk. Say it is 1, 2, 3, 4, 5. It takes 5 units of risk and correspondingly provides a return of say 1, 2, 3, 4. Okay. So, that means portfolio F has this much degree of risk and this much return. Now, can it be considered efficient? So friends, you can see one thing. F cannot be considered efficient because if you draw this point here, you can have a portfolio which can provide the same return with a lower degree of risk, say 2 amount of risk, say we call it the portfolio Z. So portfolio Z is more efficient to portfolio F because Z also takes the same amount of risk, lesser amount of risk and gives more return. F takes more amount of risk but still gives the same return. So I can say F is not the efficient one. Let's check E. E takes a risk of this much. Okay. So say 4.1. And correspondingly it gives a return of say 5. Is E an efficient point? I don't think so, because if we extend this way, we may get a point here, let's call it K, which can provide the same same return with a lesser degree of risk, say for example 2.5, right? So E is also not an efficient point. Is D an efficient point? Okay, so let's check it out. So D takes this much amount of risk, say it's 3.5, and correspondingly D gives me a return, say 5.5. So let's consider D to be an efficient because there is no such point this side which can provide the same amount of returns given the risk. Is C is efficient? So D is efficient. Is C is efficient? C takes this much risk and this much return. So there is no such portfolio this side which can provide the same. So C is also efficient. Similarly, you check out B. B is also efficient because there is no such point this side which can be substituted for B. Z is already efficient. Is A efficient? Yes, A is also efficient because A gives some return with some risk which no other portfolio can provide. Is H efficient? No, H is not efficient because same amount of, see, H corresponds to this point also. So it gives the same return but with a lesser risk if there is a point, say L here. So this way we discovered H is also not efficient. Similarly, G is also not efficient because if I extend this side, we will reach this point L, which provides the same return but with a lower degree of risk. So what we understand is that these points are eliminated and we are left with only this point. Right? We can trim this out. We can remove this point and we will be left with a shape like this. So that means out of all the portfolios, we are left with some portfolio ranging from A to D. This is our efficient frontier. That means any point on this represents different possible combination of risk and return. As I was naming K, Z, L, means this is possible. That means we can construct a portfolio which can provide this much risk and this much returns. So we have to find out that these represent different combination of risk return which are considered to be efficient. That means if any point on this frontier is chosen, there cannot be any competing point which can give you more returns with lesser risk. So that means any point on this is actually an efficient frontier or efficient portfolio. Now it depends on the risk appetite, how much you are ready to take risk and how much returns you are expecting. You can check, this is the point which gives you the minimum risk, this is the minimum risk, and this is the maximum return. So you can see D was the maximum return, no other portfolio offered maximum, and A is the minimum risk, no other provided that much lower degree of risk. So this is the maximum return. So friends, the efficient frontier connects the minimum risk with maximum return. So we connect these points, we get efficient frontier. This is also known as global minimum variance. Global minimum variance portfolio. That means this portfolio is characterized by the lowest degree of risk, okay, globally. Now the question is, we as an investor, okay, you can have one shortcut that if you have your axis divided like this, the points here will be inefficient, here also inefficient, here also inefficient. Those points which are in this zone are considered to be efficient. So that's why we had this part to be called as an efficient frontier. So if it is north, this is south, this is east and this is west. So northwest is considered to be the most efficient frontier or more efficient portfolios. Now friends, if we are investors, we are interested to know all these combinations, risk return combinations. We can have combination A, B, C, n number of combinations. We would like to have the combinations known to us before we invest. So how can we know? Now we know how to calculate portfolio risk, we know how to calculate portfolio returns, and likewise we can have different portfolios with different risk return combinations. We can have a lot of calculations and discover the different risk return combinations and find out the ones which lies in the efficient frontier. So Markowitz model is a model which believes that, or which is dependent on the fact that we can discover the efficient frontier with the help of quadratic programming, because graphically it looks very simple, but if you are going to find out all these risk return combinations, it's not so easy. So you can take help of quadratic programming and find out the efficient portfolios. Now friends, but what we need, we have to find out the variance of all the portfolios. We have to know the expected returns of all the portfolios. If there are 1000 portfolios which are efficient, that means how many variances we are calculating and how many covariances we are calculating. You can imagine, and the work becomes very cumbersome. The calculations become very complex when you are going to calculate the portfolio risk for so many combinations. And friends, you have seen in the last video that the calculation of portfolio risk is indeed very complex, because we have to calculate variances, then covariances. In the last video we have seen only with 3 securities, so just imagine there can be so many securities and we can have the changes done with respect to the weightage of A, B, C. So that's how the complications arises. So that's why people, with development, we have moved from this efficient frontier approach as been endorsed by Markowitz to some new model, that is single equation model, or you can say single index model or multi-index model, that we will see in our next video. So friends, thank you for watching this video. Please stay tuned for the next video. Till then, goodbye.